Hello everyone. Welcome to our channel, the Digital Institute of Computing Technology. In this presentation we will have discussion on the topic exception handling in Python programming language. Let's start. Firstly, let's try to answer the question: what is an exception? And what is exception handling? What is an exception? An exception is an event that occurs during the execution of a program that disrupts the normal flow of instructions. In Python, exceptions are errors detected during execution. When an exception occurs, Python stops executing the current block of code and transfers control to a corresponding exception handler, if one is present. If no handler is found, the program terminates with an error message. What is exception handling? Exception handling is the process of responding to exceptions when they arise. This allows a program to continue executing or to fail gracefully instead of crashing. In Python, exception handling is done using try, except, else, and finally blocks. Consider the program in the given example. Here, we are trying to divide variable numerator by variable denominator, with variable denominator assigned a value 0. When you run this code, you will encounter a 0 division error first, and the program will terminate immediately. Division by 0 error will cause the program to crash, and you will get the output as shown. A traceback is displayed along with a 0 division error. Let's consider another example. As shown, LST assigned 1, 2, 3, print LST of 5. Here we are trying to access an index that is out of range in a list. Here, the list LST contains 3 elements, which are integers 1, 2, 3. We are trying to print the 5th element of the list LST. This will cause an index error as the list LST has only 3 elements. The index error will cause the program to crash, and you will get the similar output, but this time with an index error. Note, in both the cases the program crashed and did not terminate gracefully. Now, can we rewrite this code in such a way so that the program terminates gracefully? Yes. This is achievable using a mechanism called exception handling. Now, let's rewrite this code with exception handling. Exception handling will prevent the program from crashing, and hence we can handle the errors gracefully. This is how the code looks. This code may raise multiple exceptions. Here, we have code to handle division by 0 exception, using except 0 division error. Next, we have code to handle list index out of range exception, using except index error. If none of the exceptions occur, we have the else block for successful operations. And we have a block called finally, which executes in all cases, whether an exception is seen or not. Now, let's examine the output of this code. The output is as shown. Error: cannot divide by 0. Execution of the try except block is complete. This line is printed because the exceptions were handled. Here, you can observe the code jumped straight to the block except 0 division error, without processing the list LST, but the program did not crash. After the except block, the final block executes, the else block will not execute, because an exception has occurred. This way the final block gets the opportunity to do necessary cleanup of the code. Now, let's understand the various blocks present in this exception handling code. Try block. This block contains code that might throw an exception. Python will attempt to execute this code. If an exception occurs within the try block, the remaining code in the block is skipped, and the control moves to the appropriate except block. Except block. This block handles specific exceptions that occur in the try block. You can specify the type of exception you want to handle after the except keyword. If the exception type matches, the code within this block will be executed. Example: 0 division error, index error, etc. Else block. This block is optional. If present, will execute only if no exceptions were raised in the try block in the current execution. It's a good place for code that should run only if the try block did not encounter any exceptions. Example: this may have code to display the results. Finally block. This block is optional. This block will execute regardless of whether an exception was raised or not. It's typically used for cleanup actions, such as closing files or releasing resources, etc. Let's consider one real-time example now. Consider a scenario where you need to read data from a file, process it, and handle potential exceptions such as the file not existing or containing invalid data. Let's write a simple function process_file, which receives file name and performs this exceptions check. Here is the definition of the function. In process_file function, we are opening the file in read mode. Let's assume the file has some sequence number in string form. Now, we are attempting to convert this data to integer. We may encounter two types of error in this scenario. A file not found error, if the file does not exist. A value error, if the file has invalid data. Next, we are handling file not found error and value error exceptions as shown. The try block will attempt to open and read the file, simulating processing of data that might raise an exception. The except file not found error block is used for handling the file not found error. The except value error block is used handling invalid data error. The else block contains code to execute if no exception occurs. And the finally block will run regardless of whether an exception was raised or not. Now, let's test the function process_file. For different scenarios, let's assume there are three files. Existing_file.txt exists in the system and has a valid data. Missing_file.txt does not exist in the system. Existing_file.txt exists in the system and but has an invalid data. Now, let's call the function process_file with each of these files and examine the output. In first case, function process_file is invoked with file name existing_file.txt. In this case, file exists with valid data. The output is processing result, which is followed by result. File processed successfully. End of file processing. In second case, the output is function process_file is invoked with file name missing_file.txt. In this case, file does not exist. The output is the file does not exist. End of file processing. In third case, the output is file exists with invalid data. Function process_file is invoked with file name invalid_data.txt. In this case, the file contains non-integer data. The output is the file contains non-integer data. End of file processing. In this example, the function process_file handles different exceptions that might occur during file operations. It ensures the program does not crash and provides meaningful messages for different error conditions. Exception handling is crucial for building robust and resilient applications. By anticipating and managing potential errors, you can ensure that your program continues to run smoothly even when unexpected situations arise. Proper exception handling allows for graceful error handling and reporting, ensuring that resources are properly cleaned up, maintaining the flow of the program without abrupt terminations. In real-world applications, there could be many other types of exceptions that need to be handled, such as file not found errors. network connection errors, invalid input errors, and more. Effective exception handling improves the user experience and reliability of your software. Now let's discuss assert and raise operations in Python. Assert is a debugging aid that tests a condition. If the condition is true, nothing happens and the program continues to execute. If the condition is false, an assertion error is raised with an optional error message. In the example shown, we are asserting if the value of the variable b is 0. A call to the function divide with values 10 and 0 will make the assert print an error message and return, breaking the normal flow. For any other value of b, the flow is normal. Usage of asserts. Asserts are used to catch bugs by verifying conditions that should always be true. Commonly used for internal self-checks in functions or during development. The syntax of an assert statement is assert followed by condition, followed by an optional error message. Raise is used to manually raise an exception. You can raise built-in exceptions or create your own. Custom exceptions. Usage of raise. Used to trigger an exception when a certain condition is met. Helps in handling errors gracefully and maintaining control over the flow of the program. The syntax of an raise statement is raise followed by an exception with an error message. In the example shown, we are raising the value error exception with an error message. Cannot divide by 0. If the value of the variable b is 0, the function divide returns with an value error exception, breaking the normal flow. Value error exception has been handled in the except block. Value error exception is a standard exception provided by Python. In its place we can define and use our own exceptions as shown. Custom error is a class inheriting an exception class. We have the function __init _ to initialize the class, and function __str _ to display error message. Now, in place of value error, we can use custom error exception. The call will look like this as shown. Just define a custom error class and use it to create a custom exception. So, this completes an overview of exception handling in Python. Hope you enjoyed and liked the presentation. Remain connected with us by subscribing to this channel for latest updates on this channel. Thank you.